Okay, so we've got calcium. It has an atomic mass of 40.078. I think they wanted you to come down right now.
Who did?
Talking to Ryan.
Oh.
And chlorine, which has an atomic mass of 35.453. You need to pay attention up here. 40.078, and this times 2 is 70.906906, and you add them together, you get 110.984. Now there's no empty slots over here on the right, so that it's perfectly okay. You don't have to do any rounding off. All you got to do is go ahead and write down that this is grams of calcium chloride. Now it's very important that you write this. Okay, you want to make sure you write down that this amount is grams of calcium chloride, and that you write down that it's equal to 1 mole of calcium chloride. Okay, what we're doing now is writing what's called an equality statement. The equality statement is what we use to build the conversion unit we need right here. We want to be able to get rid of the grams of calcium chloride we're starting with and change that into moles of that solute calcium chloride. And this is how we're going to do it with this equality statement. We're going to take the 110.984 grams of calcium chloride and put it on the bottom. We're putting this number on the bottom because the units and species, grams and calcium chloride, units and species, match the units and species here. And we're going to put the other side of the equality statement on the top, 1 mole of calcium chloride on the top. And this allows us to cancel grams and cancel calcium chloride. Okay? We have successfully, through dimensional analysis now, converted our starting solute into moles. We just have to do the math to get there. We'll get there shortly. We need to still change the solvent amount into kilograms. Right now it's in grams. We want to change it into kilograms. So we need an equality statement for this conversion as well. You can't just do it. You have to show me what it is. There's 1,000 grams in 1 kilogram. Okay? Then using this equality statement, we're going to put the side of the equality statement that matches these units right here on the top. This is on the bottom. We want this one on the top. 1,000 grams on the top, 1 kilogram on the bottom. And through dimensional analysis, we cancel the grams. And we're ready to do the math. We now have the solute amount in kilograms. So when we do that math, you can do the math now? Everybody, if you haven't already, do that math. Let's practice with your calculator so you build that muscle memory, mental muscles. You got the math done already, Michael? Trey? Okay, when I did the math, I got 0.053431. Now the units we have left are moles of calcium chloride on top of a fraction over kilograms of H2O on the bottom. You don't want to just drop something. You want to make sure you keep up with everything here because it all has a purpose. No, I'm going to round it off to 3 digits. You got more numbers than that? I was using a different calculator. Let's see what.
I got 0.05341311252.
That's fine. That's good.
Just round it off.
Well, the calculator I was using only went to that many digits, so that's fine. All right, but we're going to round it off here in a minute. Let's see. We've got 3 digits. You're going to look up here in the problem and find the measured or calculated numbers. This one is a measured number. This one's a measured number. This is a calculated number. So these 3 numbers here are those that you're going to look at when you're trying to figure out how many significant digits you want in your final answer. And this one has the least digits. That means in the final answer we need 3 digits. Leading zeros here are not significant. So this 5 is the first significant digit, 1, 2, 3 significant digits, and we underline the last 2. We're ready to round it off, and we use an arrow to show that we're rounding off, and we write the final answer as 0.0534. And since moles of the solute over kilograms of the solvent is molality, we can just simply write this as small letter M, calcium chloride solution. You name the solution for the solvent. The solute. Name the solution for the solute. You don't even have to name the solvent if the solvent's water. It's assumed or it's implied that if you don't name the solvent that it is water, and in this case it is water. Okay? Any questions about that? All right. Not hearing any questions, then let's let you try it. It's very similar. The homework didn't actually ask you to change the homework from last night didn't ask you to do any calculations. We had to change the measurement units for the solvent. Okay, so we've added that in there here. Okay. If 0.99 grams of scandium phosphate is dissolved in 999.9 grams of water, what is the mole concentration?